You need to read the problem carefully. Some of these problems are not designed to deal with f prime. If you try to find f prime, you'll probably be hanging from the ceiling. And just says where the graph of the function is concave up, concave down, and the coordinates of all inflection points. That means they're only looking concavity, so this guy only deals with, and I need to change this, g double prime. Now I still have to find g prime, but I don't have to take g prime set it equal to 0. We're only looking for concavity, so it's going to come from g double prime. The problems in your book, and this one is one of them, is not designed for you to be able to take the first derivative and set it equal to 0 and solve for x. You'd have to use technology in order to do that. So we'll go with g prime of x. This is 15 x to the fourth minus 60 x cubed plus 11. Now if I try to set that equal to 0, good luck in trying to solve that equation. That's a fourth degree polynomial. The only way I could do that is Wolfram Alpha, Mathway, my calculator. I need a piece of technology to be able to solve this. Why? Because it can't be factored. And I don't have a formula to do a fourth degree. There's no quadratic formula. And so let's ignore him and go to g double prime, and this is 60x cubed minus 180 x squared. Something's not right.
Yeah.
That should be 100, not 60. I don't know where I got 60. My mind wandered, so that's 300. X squared. Now notice, this is the guy I'm going to set equal to 0, so he makes sense. So I want f double prime equals 0, and where f double prime does not exist. Well, f double prime exists everywhere. It's a polynomial. He doesn't have a problem, so there's no critical points coming out of here. So he's okay everywhere. So we're to 60 x cubed minus 300 x squared equals 0. Well, it's got a greatest common factor of 60 x squared. X minus 5 equals 0. So that x equals 0, x equals 5. So I've got two critical numbers. And I know, by the way, that 0 is not a point of inflection. Why not? Zero is what multiplicity? He's an x squared. 2. Is there a change across 0? No, if there's no change, you can't have a point of inflection there. Got to be a change. Points of inflection is you change from concave up to concave down. There's not going to be any change across 0. This is multiplicity 1. So there is a change. There's no change. So then I go to my number line. I still have to include 0 and 5. No change, change. And pull a test point. I'll pull x equal 1. So 60 times 1 squared times 1 minus 5, positive or negative. Negative. No change, negative, positive. So he's concave down from minus infinity to 5, concave up from 5 to infinity, and that says concave down followed by concave down. He continues to be concave down, then he moves to concave up. So you have that inflection point there. So inflection at 5 something, and they want us to do that calculation. If you have your graphers, one way of doing it. And by the way, it works the same way, whether you're on one of these guys or here. That's going to be one of the nice things. And let me clear my screen. We're just going to do it brute force. And whether you have a graph or whether you have something that looks like this, I want to put in 5, so x equal 5. It would be 3 times 5 to the 5th minus 25 times 5 to the 4th plus 11 times 5 minus 17 That's a different number than I got first hour. Yeah. Now I made a mistake, and I don't want to retype this in. And by the way, this works with this calculator as well. The only difference is you hit the up arrow, and I'll explain that. So second enter brings it back, and I just need to change that sign to a subtract. That's better. Negative 6212. So that gives me the coordinate point. So this is what they're after for this problem. Now, what these calculators have is called deep memory. Now, it's got a temporary, what we call buffer, in the calculator itself. So with the graphers, I can filter through the buffer. So that says if I say second enter brings back what I just did, second enter brings back the previous one, second enter brings back the previous one. That's what I did in the first hour. Second enter, second enter, second enter. The downside with the graphers is that you have to kind of wait for it. It'll eventually come back to where you started. And it only holds so much. Holds quite a bit, as you can see, in terms of calculations. Now I'm back to where I started with the calculation. So you can bring it back, recalculate. And why is that? Well, suppose what I wanted to do was, instead of having a 5 there, put a 1 there. Well, I just changed the 5 to a 1. And recalculate. So it allows me to do multiple calculations. I prefer what I did in the other hour, however, which is essentially taking 3 and then parenthesis 5 parenthesis to the 5th power. And that way I just come back and change what's inside the parentheses so I know what that is. There are other ways of doing this, and if you know that way of doing it, that's fine. This is kind of a brute force way of using your calculator and letting it do the work for you, where you end up having to do multiple calculations. If I had more than one inflection point, that would have been quite handy for me just to go back, pull back the equation I just did, and just make the substitution of the new number. Yeah?
Why do you choose 5?
Because that was the value of the inflection point.
Where it changes?
Yeah. Okay. Now, if you're on the little guy, he has a buffer as well, and I know this is harder to see, and I can't, since I'm videoing, I can't change the, what would it do? I'd have to change the brightness. And so once I'm there, it won't let me, I don't think. It won't let me change anything. But if I were to say 3 parenthesis 5 parenthesis to the 5th, and hopefully you can see a little bit of that anyway. There it is. I'm not going to take the whole thing out, but in order to bring it back to make changes, I just hit the up arrow. And what that does is bring it back. Now, it's got a buffer, just like the grapher does. it really is called a stack is what it's called. It's a stack of commands. And it allows me to scroll through the commands that are in there, well, the things that I did. The nice thing is I can move up and down in that stack till I get back till I get to where I want. Well, I can't do that with the grapher. The grapher only goes one direction, and until you keep hitting second enter until you get it back to where you want it. Once you passed up what you want. Okay, so these guys work quite well too. And these are $12, something like that, in terms of working with it. So that also becomes quite helpful.